All right, this video is going to cover chapter 7, sections 4 and 5, which is properties of special parallelograms. So we're going to start to get into squares, rectangles, rhombuses, and then kites and trapezoids. So we start with rectangle, rhombus, and square. So all three of these are parallelograms, which means all the properties of parallelograms carry over with them. A rectangle is specifically a parallelogram with 4 right angles. So in my rectangle, I know by definition 4 right angles. A rhombus is a parallelogram with 4 congruent sides. So in my parallelogram, now 4 congruent sides. That's a rhombus. And a square is like if a rectangle and a rhombus had a baby. It's both. It has 4 right angles and 4 congruent sides. So now you've got the 4 sides and the 4 right angles. The rhombus corollary, so this is just properties of rhombus. You don't need to know that it's called the rhombus corollary, but it basically says a quadrilateral is a rhombus if and only if it has 4 congruent sides, which is just what we said about the definition. The rectangle, a rectangle is a rectangle if and only if it has 4 right angles. And square, it's a square if and only if it is a rhombus and a rectangle. So again, the square has all the properties of the rhombus and all the properties of the rectangle. This is a Venn diagram of your 4 shapes, so we're going to eventually get a little bit more detailed into this, but this Venn diagram, first of all, the big picture would be quadrilaterals because they all have 4 sides. Then it gets to be more narrow and you break it down into parallelograms, which means opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Then within parallelograms, you've got rhombuses, which have all the same properties as the parallelogram, plus 4 congruent sides. You've got the rectangle, which has all the same properties as parallelogram, plus 4 right angles. And then you've got your squares that have all the properties of all the parallelograms, all the rhombuses, and the rectangles. The rhombus diagonal theorem. Again, it's a name for a theorem, but really what it says is important. It says a parallelogram is a rhombus if and only if its diagonals are perpendicular. So we know 2 additional things about a rhombus after its definition, and this is the first one. Diagonals are perpendicular, which means they're going to form that right angle. The second is the opposite angles theorem, and it says a parallelogram is a rhombus if and only if AB bisects angles BCD and angle BAD. So these diagonals bisect these opposite angles, which means it cuts those 2 into 2 congruent parts, and it cuts these 2 into 2 congruent parts. We know more about a rectangle by way of its diagonals. So in addition to knowing that there's 4 right angles, in a rectangle, the diagonals are congruent. So these are bisected and congruent, which means each of these 4 parts would be congruent. Okay, so example 1 says quadrilateral ABCD is a rhombus. Find the measure of each angle. So if it's a rhombus, obviously we know all the sides are congruent and all that stuff, but now we also know that the angles, these are congruent and they are bisected. So this guy equals this guy, which is going to be the same over here. This would be 62, this would be 62, this would be 62, which answers ACD is 62. DEC is the central angle here, or where the 2 diagonals meet, and we know because it's a rhombus that those are perpendicular. So that's going to be 90 degrees. All of these would be 90 degrees. EDC is this angle in here. So there's a couple different ways to figure this one out. One is these have to be supplementary, so I can add the 60 to the 62 to get the 124 here. Subtract it from 180, which would be 56, divide it into 2, and you'd get these 2 angles. The other way to do it is that this is a right triangle. So 62 has a complement of 28. And then I know this is 28, and this is 28, and this is 28. So you can do those either way. Use the consecutive interior or the consecutive angles in your parallelogram being supplementary, or you can use your right triangles here. So EDC is 28 degrees, and ABC is 28 plus 28, or 56 degrees. All right, example 2 says quadrilateral ABCD is a rectangle. So this time we know all the properties of the parallelogram, all the properties of a rectangle being that the angles are 90 degrees, that the diagonals are congruent, and the diagonals are bisected because it's a parallelogram. So if I want to find PON, I know it's 90 degrees because the definition of the rectangle. PMO would be this angle in here. And since these two have to add up to 90, I can do 90 minus the 29, and I get 61 degrees, which would be PMO. PL is this part of your diagonal. Since LN is 12, and it's a parallelogram, these are bisected, which means PL would also be 12. And then MO is your other diagonal, but in a rectangle, diagonals are congruent. So if I add the 12 and the 12 to get 24 for this whole diagonal, MO would also be 24. All right, example 3 says quadrilateral MORE is a square. So if it's a square, all the sides are congruent. All the properties that we know about both of them are here. Opposite sides are congruent, and all of them are congruent because it's a rhombus. All the angles are 90 degrees because it's a rectangle. Diagonals are perpendicular. Diagonals bisect each other. Diagonals are congruent. So ME is 7x minus 3, and MO is 6x. In a rhombus or a square, these are congruent. So 6x equals 7x minus 3. Negative x would equal negative 3, and x equals 3. For B, it says MT is 4x, and TE is 3x plus 2. Since it's a rectangle and a rhombus, the diagonals are bisected, and they are congruent, which means 4x would equal 3x plus 2. And x is 2. OE is double that TE. So I'm going to find TE, which is 8. And then TO would also be 8. So OE would be 16. All right, chapter 7, section 5 is properties of trapezoids and kites. So 2 new quadrilaterals. What's different about these is they are not parallelograms. So they're quadrilaterals, which means that they have 4 sides, but these are not parallelograms. A trapezoid is a quadrilateral with exactly 1 pair of parallel sides, which is why it's not a parallelogram. You would need both pairs of parallel sides. Each of the parallel sides is called the base, and the non-parallel sides are called the legs. The base angles of the trapezoid are the 2 consecutive angles whose common side is a base. So the parallel sides are your bases. The non-parallel sides are your legs. The base angles are where the leg meets the base, where the leg meets the base. And they are in pairs. So this is a pair of base angles, and this is a pair of base angles. An isosceles trapezoid is a trapezoid in which the legs are congruent. So the 2 sides here that are non-parallel are congruent. These are our properties of trapezoids. So theorem 814, you just ignore that number, okay? And what it says is important. That if a trapezoid is isosceles, each pair of base angles is congruent. So this pair, B is congruent to C and A is congruent to D. Again, ignoring these. The next one is that the pair of congruent base angles, if it has a pair of congruent base angles, then it's isosceles. So if I know these are congruent, then I can determine that these are congruent and it's isosceles, so it's the converse. And the last one is the diagonals are congruent. So like a rectangle, the diagonals on an isosceles trapezoid, not any trapezoid, but an isosceles trapezoid, are congruent. All right, trapezoids with mid-segments. So we did mid-segments of triangles. These are very similar. The mid-segment of a trapezoid is the segment whose endpoints are the midpoints of the legs. So it still connects the midpoints of each of the legs. And the trapezoid mid-segment theorem says the midsegment of the trapezoid is parallel to each base. So instead of it just being parallel to one side like the triangle, it's parallel to each base. And the length is 1/2 the sum of the bases. So it is base 1 plus base 2 divided by 2, or 1/2 the sum of base 1 and base 2. Doesn't matter which one's base 1 and which one's base 2. You just add them and divide by 2. The kites are next. So a kite is a quadrilateral with exactly 2 pairs of congruent consecutive sides. Again, not a parallelogram. What's important here is that the sides are consecutive, meaning these two would be congruent and these two can be congruent, not opposite each other. So that's why it's not a parallelogram. The opposite ones are not congruent, just the ones that are consecutive. So this would be kite A, B, C, D. Properties of kites are a quadrilateral is a kite, then the diagonals are perpendicular. So like a rhombus, the diagonals are perpendicular. And if quadrilateral is a kite, so only one pair of opposite angles are congruent. And it's the angle where the two non-congruent pairs meet. So angle A and angle C in this diagram cannot be congruent. Those would be different, but angle B and angle C are congruent. All right, so here's our questions. This one just says find the measure of angle A, and from this diagram, this is an isosceles trapezoid. I know it's got one pair of parallel sides, and I know the legs are congruent, which means the base angles are congruent. So this would also be 100, and it means that the consecutive angles are supplementary. So this would be 80, and this would also be 80. Example 2, and again, an isosceles trapezoid because of these. This would be 49, and these would be supplementary. So this is going to be 131. Example 3 says KB is 21.9, MF is 32, this whole thing is 32.7, and it wants you to find FB. So in a trapezoid, that is isosceles, which is this case, the diagonals are congruent. So this whole side here would also be 32.7 degrees. So if I want to find this smaller part, I just have to do 32.7 minus 21.9. And I get 10.8. Example 4, now we're talking about a kite. So it says in kite ABCD, angle DAB, which is this angle here, is 54 degrees. And angle CDF, which is this angle here, is 52 degrees. Find the measure of angle BCD. So remember in a in a kite, these are perpendicular if we need to know that information. And we also know that these would be congruent because these are my congruent sides, these are my congruent sides. So angle B equals angle D, so this would also be 52 degrees. So this is an isosceles triangle in which you've got 52 and 52, that's 104. That top angle would be 180 minus the 104, which is 76 degrees. All right, and we can skip example 5, and you can move on to your packet. Have a great day, guys.